There we go.
Okay. Thanks, John, for the introduction, and thanks for organizing this nice workshop. So I'd like to, welcome all of you. Good morning, good afternoon, good evening, wherever you are, and welcome to this tutorial about geospatial data management in AsterixDB. So today I'll be presenting this work along with Akhil Sevim and Tin Vu on behalf of all the authors. So what to expect in today's presentation? So we'll start with a quick overview about what AsterixDB is and what it provides, and then we're going to talk about the geospatial data support in AsterixDB, because this is the scope of this workshop. We'll also talk about how to load data into AsterixDB, and then we'll also show you how to connect to AsterixDB instances. So we'll provide all these instances for you on the house, so you can just directly connect to these and start working. All you need is just a browser and 5 seconds of your time to connect, no more than that. And then we're gonna work together, get hands-on experience in data querying and processing in AsterixDB. So let's start with describing what AsterixDB is, right? So what is really about AsterixDB? So in just very short words, it's a parallel NoSQL database system, right? So it's a parallel database system. It supports NoSQL or semi-structured data. And if you think about the wish list in a system like that, you really need to be able to manage your data. You need to be able to insert your data, process it, build indexes on it, run queries on it. You want also a flexible data model, so you don't want to be restricted by the tabular form of traditional databases. You want to support nested data and all these nice features of JSON data support. Okay. You also want full query capability with a simple query, like declarative query language, like SQL or SQL++. You also want to continuously ingest your data because your data is continuously growing, and you want to be able to absorb and ingest all these data. Of course, you want all these queries to run in parallel because you want to scale to big data. And you want the cost of your queries to also be proportional to the task at hand. So you don't want to scan the entire data if your query is just accessing a few records. You want somehow to run it more efficiently if you are accessing few records. And more importantly, you also want support big data types. And this is actually part of what we're going to talk about today, how to not just support textual or like numeric data, but you also want to support textual data, you want to support points in space or time. So when we thought about AsterixDB and what we want to provide there, we wanted to take ideas from semi-structured data processing, semi-structured systems or data management system. We also want to take state-of-the-art parallel database system ideas. We also want to take ideas from first-generation big data tools like Hadoop and Spark, right? So we want something that at the end is like a parallel database system. It supports all of these features in one system, right? So you can do all of these in a parallel database system. And when we talk about big data, a question that usually comes is how big is big data, right? There are different perspectives of that. And our perspective in AsterixDB, which we work on, is the data that cannot fit in the main memory of a cluster of machines, right? So you cannot just keep your data in main memory. It's much bigger than that you need to push it down to disk. So think about historical data that does not really belong in main memory, does not really fit in main memory, and you want to be able to support all these data. So this is the scale that we are talking about here, supporting in AsterixDB. And talking about the storage of these data, we keep all these data in AsterixDB in a partitioned, like log structured merge tree. So you have all these data on multiple machines, and you also build multiple indexes on it. So you can build B+3 indexes, R3 indexes, text-based indexes. So you can build as many indexes as you want on these data. And all of this is provided with a simple SQL++ declarative query language. So all you need to know about is just how to write these SQL queries. And we also support SQL++, which further extends that to NoSQL data, semi-structured data, window queries. So it's much stronger and much richer than SQL. So we gave you a quick overview of what AsterixDB is, but the scope of this tutorial is geospatial data support. So one of the features of AsterixDB is that it supports geospatial data types such as points, lines, and polygons, and all of these follow the OGC standards from the ISO standards. So these queries, this comes not just with the data types, but also all these operations, all standard operations and the queries you can run on them. And you can check the documentation of AsterixDB to find more details about all these functions and how they work. But the one point I want to highlight is that these standards are also supported by many other systems, such as PostGIS or SQL Server or Oracle Spatial. So if you have any queries that are already designed for these systems, with very little work, you can just make it work on AsterixDB, and you don't have to make major changes because all of these systems now follow the same standards. So to give you an idea about what AsterixDB can provide, just give you a short example from a system called the Cloudberry, which is powered by AsterixDB. It's a system for visualizing, querying, and analyzing Twitter data. So I just logged in this morning, and currently, as you can see at the bottom left, we have more than 2 billion tweets indexed by the system, and the system is continuously ingesting more data. So from the live stream of Twitter, it just gets data and absorbs it and ingests it into the system. And just this morning, I tried to search about the word muertos, so to see how people in the US tweet about Dia de los Muertos, which is Day of the Dead. It's a celebration in Latin America. And if you saw the movie Coco from Disney, you know what I'm talking about, right? So it's also celebrated in the US by the Hispanic population. So as you might expect, when I search for this word, you can see that most of the tweets are concentrated in California, Florida, Texas, where the Hispanic population lives. But you can also see at the bottom here that you see this annual pattern, because this is an annual celebration. So you can also see that directly from the bottom here. And you can also click on any state you want and find more information about the distribution of data over this place. So you can see here that all of these features are powered by AsterixDB, and now we are able to process text data. You can search by keyword. You can see queries by time and by space. This is continuously ingesting more data. It's working with big data. So this gives you an idea about what AsterixDB can provide. And in this tutorial, we're going to explain to you how to use AsterixDB. So last point I want to mention before moving forward is how you can find and load data into AsterixDB. And I'm going to focus on UCR Star, which is another system that we host here at UCR. It's an archive which currently contains more than 3 terabytes of data. And if you want to import some data from UCR Star into AsterixDB, all you need to do is just click download, choose any dataset you want, click download, and choose the JSON plus WKT format. And this is one of the formats that are supported by AsterixDB. So at this point, I'm going to hand it over to Tim, who are going to explain to you in more detail how to work with AsterixDB.
Tim, we cannot hear you. Tim, we cannot hear you. We cannot hear you. So let's wait for a few minutes. I think Tim is rejoining the meeting.
Hello?
Okay, we can hear you now.
Oh, okay. Sorry for the
yeah, no problem. So let me make you as co-host so you can share a screen.
Okay, let me share my screen.
Volume is pretty low though.
Yes, a little bit low.
Oh, okay. So is it better now?
Yes.
Okay. Can you see my share screen now?
Yes.
Oh, okay. Sorry for some problem with Zoom. So, yeah. I hope that you are excited with what Ahmed that introduced about AsterixDB and the capabilities that AsterixDB can provide you to help you to solve your data analytics problem. So in the next part of this tutorials, I will uh, give you a brief introduction that how we can load your data to Apache AsterixDB so that you can start have some hands-on experience and run your analytics queries on AsterixDB. So as I might introduce about the UCR Star before, in this tutorial, we will use the first dataset is Tiger 2018 ROS dataset. You can go to UCR Star to download it or use this link. The raw dataset includes some information, some attribute like the IDs or the geometry, which is the line string of the data. And you can download the full dataset or a partial dataset. It depends on you. The second dataset we are using is the Geo Open dataset, in which you can go to geo.com/datasets to download this data. And Geo provides 5 different datasets, but in this tutorials, we will use the business location endpoints datasets, and they have about 8.6 million reviews and about 160,000 business. For geology views, you can see here they have some attribute like IDs or text or business IDs. So we can go into detail for each dataset later on. So this is a AsterixDB user interface in which we will soon give you the information how you can access the instance of AsterixDB that we already configured and set up. So it will take us a few seconds to access to this user's interface. Before you can run your queries and analyze your data sets, the first thing you have to do on AsterixDB is create a dataverse. So a dataverse is a concept in AsterixDB which can contain a lot of data sets in different data types. So the queries on the slides is how you can create a new dataverse, and you can create any dataverse with your desired name here. So before you run any queries, don't forget to select the dataverse. So when you have a data set, let's say we have a raw data set before, you need to create a data type for this data set. So after you use the dataverse, this statement, create type raw type as opens with ID, UIDs, and geometries, is a statement that helps you to create a new data type in AsterixDB. So it's kind of, similar to SQL, but you can see some interesting features in AsterixDB here. For example, we have as opens keywords, in which this feature allows you to change the schemas of the row type in the futures, which is kind of flexible in big data world. So after you have the row data type, you can create a data set rows with the entity type is row type, and the primary keys is IDs, attributes of the row type. And now you have the data set. You can load the data that you download from UCR Star to your data sets using this statement, load data set rows using local file system, and then the path to those the data set you downloaded. So you can do the similar thing with the geo business data set with its own attributes and similar concept of how we create data type, create data set, and load data set from the local file system. And we have also do the similar thing to geo reviews. An interesting features of AsterixDB is that you are not only able to load the data from the local file system to AsterixDB and do the query on that, but also you can run the queries on top of the data that you store on Hadoop file system or the local file system. So you don't need to know your data to process them. You can do the queries on top of data from your existing storage system. So this is some thing that's good for in situ processing for static data. So after you load the data, you can do some modification statement like insert a new record to an existing data set. For example, this statement inserts a new record to the gel review data set. You can also delete the data from your existing data set. And also another interesting keyword in AsterixDB is upsert, in which you can update an existing record if it already exists, or insert the new record if that record is not exist. So this a little bit different to insert command, because insert will be fail if the record already exists, but upsert will not fail. It will update the existing records. So in the next part, my colleague AQ7 will walk you into some interesting queries that you can run on top of AsterixDB.
Hello, everyone. Thank you, Tim. So first thing I would like to do is like share with you a link. So I will share it via chat on Zoom. So let me type it down. So this is basically a link to a domain called AsterixDB.rocks. So you can also type it to the your browser. But like when you click this link, which I just posted on the chat, we'll redirect you to a screen like this. So let me open it for you in this part, and we can check it together. So like the first thing you will see in this page is, it asks you for an email address from you. So this, like why we want this is like, we want to match you with an dedicated instance. So currently we have like 20 machines there. So we will just, try to distribute all these machines to all the attendees, and you will have your instance. And whenever you click this link, AsterixDB.rocks, and when you enter the same email address, you will have the same instance from us. So in that way, you can, reach your instance every time you type your email address, and you can continue from wherever you left from the previous part. So after you enter your email address here, you will see a screen like this. So in this screen, on the left, we see AsterixDB's user interface. So this is like, when you download and install AsterixDB, you will have something like this, as Tim shown before. And on the right, you will see the queries that we are going to use in this tutorial. So we have 8 queries to run, and then we will start from the one and continue as we move on. So I hope everybody is able to click that link and have an access to an instance. So I will just check how many of you have reached an instance. So I will just try to wait a bit here to let you to go in there and have an instance. So like, basically you can just like whatever you want in the email section. We just want to have something unique to match you with an instance. And since we are not going to terminate all these instances until the end of this conference, you can like, after this tutorial, you can even go and try the queries, or like you can just write your own queries and try to see all these possibilities that AsterixDB will provide you. So does anybody have a problem about reaching the instance? Like if you have problems, you can just type on the chat if you want, or you can just ask a question directly right now. Okay. So I only see just 5 people using it, but it's okay. Like let's continue. Like as I said, whenever you have this link, you can go there and you will see all the queries. and then you can continue. You can run, any query that you want by using the dataset that we loaded for you. You don't need to, do it during this tutorial, but afterwards you will be able to run them still. So let me start with the query.
So are those servers going to be available even after the tutorial?
Yeah, this will be available even after the tutorial. That's
awesome.
Yeah, until the end of the conference, by the way. Since we opened, turned on 20 machines right now, and it's not cheap, so it will be available at the end of the conference for just you to use. And as I said, the query is there. You can just copy and paste the query and see how it works. So let me start from here. And as I said, you will just need to type an email address. That's the only requirement. Okay, so let's start with the queries. So as Tim told, we have this upsert in AsterixDB, right? So upsert, as Tim described, is kind of an update, but it works in a different way. So we use it in this tutorial in this way. So we have this Yacht Business dataset, right? So in Yacht Business dataset, by default, we have just latitude and longitude as doubles. But in AsterixDB, we are able to handle geometries. And we have this spatial data type, geometries, which is a standard kind of standard data type. So, for example, by using this upsert query, you can create another field in this data set, which is called G, as we described here. And then you can make points by using these two doubles. And then this will not just, this will not just create another data set, or it will just not create another separate file for you. It will just add another field for you, and you will be able to use these geometry fields in the spatial queries. So, first thing, we need to run any other query in the user interface. You just need to run this first query. So if you are using the query interface right now, you can just copy this query and paste here, and then you can just click execute query to run your query. So it will be finished very quickly, and then afterwards you are able to see by clicking the data sets, and after clicking Spatial API 21 here, this is Dataverse of we are using, and if you click the Yacht Business dataset, you will see this new field type here, which is called field here, which is called G, and its type is geometry. So after now, we can use other queries, other special functions by just using this G. So our next query is this is for finding the businesses in the University of Texas Austin. So this is just English explanation of the query, but it's basically finding all the points in a polygon. So but what we do here is we just giving the polygon in hard-coded in the SQL query, but it's in GeoJSON format. So we use this stgeom from GeoJSON function to be able to use this polygon. And then by using stcontains function, we just filter the businesses just located in the University of Texas Austin's campus. But still, yeah, like we do it previously, you can just copy the query from the right and paste, and then you can run this code by yourself. So the next query is, again, we are using the single data set here, this kind of a filtering query. So, but right now we are using stdistance, and we have a road, shown like the picture here. This is the 6th Street at Austin. So we just want to find all the businesses nearby the 6th Street. But something we do different here is, in Yacht Business dataset, we have categories, as you can see here. So it's kind of a string separated by, joined by a comma. So what we do here is we just use word tokens function from AsterixDB. So what it does is tokenize all these categories. And then we, as you can see here, we kind of join them with the data set again. So in that way, we are able to find the average stars for each category, which, for the businesses, which is close to this line string. And it's obviously a street here. So this is also showing the capabilities of AsterixDB, with the usage of some spatial functions. So also you are able to run this query by copy and paste by using the query interface. So here we have another query. Here we are using like 3 data sets at the same time. So this is a join query, and the join, we are joining all these 3 data sets, and we are counting the number of reviews which has the 5 stars for each business on each road. So this is kind of a heavy query. So like it takes like approximately 10 seconds. But AsterixDB is also, handle like, this query, which has spatial filtering function again. So this is another example of how we use spatial functionality of AsterixDB. And so, I can wait a bit, like if you are trying to run this, or like, I can just go over. So like in this query, we have something special again. So like, this is joining 2 data sets, still like business and roads data sets. But what we are trying to find here is, we want to find the top 10 roads, and these roads should have the most 5-star businesses relative to their length. So this is kind of a, this is of course like maybe like not that useful query, but still it's something shows how AsterixDB is able to answer these complex queries as well. So in this one, we still use ST-distance to find each business close to each road, but we are filtering the businesses if they have 5 stars or not, and we are grouping these things by the road IDs. And since grouping hides the other fields from us to use, we are using group as function of AsterixDB here, which is just make the other things other than group by elements visible again. So by doing that, we are able to extract each point close to each street again. And also we are ordering the roads by the number of 5-star business divided by their length. So also we are using ST length here, which is just computing the length of the road here. And when we order it, we have these results, right? So also in select part, you see something, going on here. So this is also a, result of how SQL++ is flexible in this point, at this point. So after you run this query, so you can just, so I will just run this query with you. Here, query 5. So it will produce 10 roads for you along with the points in nearby that roads. And here we have options for how we see the data sets, right? So if you just go and see the JSON-NL, it just gives you the results line by line as JSONs. And then when you just go any JSON GeoJSON visualizer, you can just copy and paste this data, and then it will show you the results of these data sets for you. So like, what I'm trying to show here is AsterixDB is like SQL++, AsterixDB by using SQL++, it allows you to run very flexible queries. And also, you can use the result in anywhere you want in this way. So I will continue to the next query. So, so after this query, we have, I would like to talk about some index of options in AsterixDB. So AsterixDB gives, like multiple indexing options to you: B3, R3, keyword indexes, full-text n-gram indexes. So what we are trying to, and also like I would like to mention here that whenever you create an index in AsterixDB, it's also stored like the data sets that you have. And if you insert some data sets after you load the data sets to your database, Dataverse, if you insert some new data set, you don't need to create a new index, right? So it will be dynamically updated for you. So this is kind of an advantage of AsterixDB again. So in this query, what we do is, we just create some indexes to improve the similarity functions query joining the performance of AsterixDB. So I will just be quick as possible after this point. So like, when you run this query, it should be finished in like 300 seconds without an index. But if you create the index, it will be finishing in like, close to 40 seconds. Like this is just a basic query which joins two data sets by using the similarity Jacquard function. So after now, I will just show the queries and be quick as possible and let you to use the interface after this tutorial. So this is another example of how we combine all these advantages of AsterixDB. Here we use similarity Jacquard still to join two data sets by using the text fields, and also we apply a spatial filtering to restrict the area with a polygon. So you can also run this query and it finishes in a very fast way. So I think we are done. Thank you for your attendance. And as I said, this address will be available until the end of the conference. Please feel free to use it. Please use it and give us some feedback, or like if you have any concerns and ideas, we are happy to hear it. And as you said, you will have the same instance every time you connect. Thank you.
Thank you guys for the great presentation. So by the way, probably you can post your link to our Slack channel. So basically, that way, so even after the Zoom meeting, so people can still get access to the Slack channel and still get access to your URL, so can play around with it.
Exactly.